There are 13 planets in the solar system, or more when Pluto was demoted from the planets. The rule of good manners was to know that there are only 8 planets in the solar system. However, at the same time, a new category of celestial bodies was introduced: dwarf planets. These are underplanets that have a rounded or close to its shape, are not anyone's satellites, but at the same time cannot clear their own orbit from less massive competitors. Today, it is believed that there are 5 such planets: Ceres, Pluto, Ganymede, Eris, and Makemake. The closest to us is Ceres. In a year's time, we will learn a lot more about it than we do now, thanks to the Dawn probe. So far, we only know that it is covered with ice and water evaporates from 2 points on the surface at a rate of 6 liters per second. We will also learn about Pluto next year, thanks to the New Horizons station. In general, just as 2014 will be the year of comets and cosmonautics, 2015 promises to be the year of dwarf planets. The rest of the dwarf planets are located beyond Pluto, and we will not learn any details about them soon. Just the other day, another candidate was found, although he was not officially included in the list of dwarf planets, as well as his neighbor Sedna. But it is possible that they will find several more larger dwarfs, so the number of planets in the solar system will grow even more. The Hubble telescope is not the most powerful thanks to the enormous volume of images and the impressive discoveries made by the Hubble telescope. Many have the idea that this telescope has the highest resolution and is able to see details that cannot be seen from Earth. This was the case for a while, despite the fact that large mirrors can be assembled on telescopes on Earth. The atmosphere significantly distorts the images. Therefore, even a modest mirror with a diameter of 2.4 meters in space by earthly standards allows you to achieve impressive results. However, in the years since the launch of Hubble and terrestrial astronomy has not stood still, several technologies have been developed that allow, if not completely get rid of the distorting effect of air, then significantly reduce its impact. Today, the most impressive resolution can be given by the Very Large Telescope of the European Southern Observatory in Chile. In the optical interferometer mode, when 4 main and 4 auxiliary telescopes work together, it is possible to achieve a resolution exceeding the capabilities of Hubble by about 50 times. For example, if Hubble gives a resolution on the Moon of about 100 meters per pixel, hello to everyone who thinks that this is how you can view the Apollo landers, then VLT can distinguish details up to 2 meters, i.e., in its resolution. American landers or our lunar rovers would look like 1 to 2 pixels, but they will not look due to the extremely high cost of working time. A pair of Keck observatory telescopes in interferometer mode are capable of exceeding the Hubble resolution by 10 times. Even individually, each of the 10-meter Keck telescopes, using adaptive optics technology, is able to surpass Hubble by 2 times. For example, a photo of uranium. However, Hubble does not remain without work. The sky is large, and the camera coverage of the Space Telescope exceeds ground capabilities. And for clarity, you can see a complicated but informative graph.